Thank you. Today I want to talk about, this is part 2 of the Time 100 Best Inventions of the Year. Actually, now this feature at the end of last year is, there are 200 inventions. I guess we've gotten twice as creative, and these inventions are from all around the world. And rather than just doing random ones, I wanted to get a theme. And the theme is around green energy here. And because batteries are so much in the news, you probably may have seen in late October, the Department of Energy invested $2.8 billion in 20 U.S. battery companies to help us make us more energy efficient, right? Or not be dependent on overseas sources for this. So I've got 3 batteries I want to share with you. Before I do that, though, I want to give a nod to Elon Musk. And of course, his battery technology has helped us with electric cars, obviously. And the creative principle that I see when I see some of his interviews of how they got there was really, as an engineer, they say, well, what are the first principles? And from an ideation standpoint and creative standpoint in your company, the way to get there is very easy if you don't have an engineer on staff. It's really to say, what are the assumptions we've made about this industry, right? Or this project or whatever it is. So the questioning assumptions technique. So let me give it just a really quick history of batteries. You know, I don't know if you know, but in 1903, after 10 years of research and almost 15,000 experiments, Edison launched the nickel-ion storage battery. And it was developed at that time for what? For cars. It didn't turn out to be workable and efficient. The internal combustion engine kind of beat them out there, but it was used on submarines, etc. So what's interesting is that now Silla Nanotechnology, it's a California-based firm, they actually have spent 10 years developing a silicon-based battery that replaces the graphite in the traditional batteries, car batteries, lithium-ion batteries. And so they were one of the firms that actually got $100 million from the Department of Energy to go scale up on this battery. By the way, the graphite is in the anode section, and it turns out that they, and by the 55,000 iterations to get there, so this was a 10-year thing, just like Edison, this battery will be 5 times lighter, and 2 times smaller than the ones with the graphite in them, and they'll increase energy capacity 20 to 40%. And with this Department of Energy grant, they're scaling up their Washington factory. So that's battery 1. All right. So let's look at battery 2. Talk about questioning assumptions, right? If we think of a battery, it's got all this metal in there, right? Well, there's the Swiss National Lab, EMPA, has developed a battery, if you can believe this. It's water-activated disposable paper battery. So what they've done is they put graphite in one. The paper itself is, sodium chloride, salt infused, and on either side you have sort of zinc ink, and the other side you have graphite ink, and you can activate this with water. And you say, okay, that's the nice kid experiment, but you can actually use this for smart labels, for tracking objects, environmental sensors, medical diagnostic devices, and the output is pretty good. It's 1.2 volts versus traditional alkaline battery, which is 1.5 volts. All right. The third battery, this is, I'll give a nod to Peter here. This is it's based on an IBM advance in chip technology. This is IBM has developed the 2 nanometer chip, right? So 2 nanometers. So what that means is you can get 50 billion with a B, 50 billion transistors, basically in the space of your fingernail. So these transistors are about 5 atoms each, right? So what does that mean in terms of batteries? By the way, the creative principle here is looking at upper limits, right? What's the upper limit, right? So they're projected to quadruple the life of cell phones, right? And obviously also they'll slash the carbon footprint of data centers. And this is not in the theory stage. This has gotten very practical. Samsung Semiconductor, the Louis Semiconductors, are battling it out to get this chip out by 2025. And the U.S. and Japan have created a research center to develop 2 nanometer technologies. All right, so there we go. That's the green energy thing. I thought, as a fun thing, Mary said I could take a minute of her time and do a fun energy thing. As we all know, the AI content creation programs, which I've talked about in a previous Curious and Quirky episode. I thought it would be fun to do a Curious and Quirky poem about what? The Caltech Curious and Quirky podcast, right? So the question I put in there was write a poem about Caltech's futuristic, curious, and quirky podcast. There are 6 quatrains that came out of this. The first one didn't work because it tried to rhyme boast with podcast. That didn't work, but here they are. Exploring the unknown, a world of surprise, sparking conversations with questions so wise. The sciences explored from biology to math, robotics and AI, a scientific path, a brilliant adventure, a journey to space, exploring new frontiers, a journey with grace. The podcast, a haven, a place to learn, thoughts and ideas to our minds they burn. The future awaits, a world so new, curious and quirky, Caltech's podcast so true. So that, came in a flash, right? Less than a second that appeared. All right. So I think that was fun. That's the kid in me, right, Mary?